So in this video, we're going to look at using the chain rule, and we're going to look at it in a case where we also have to use the general power rule. So we have f of x equals x to the 7th minus 5x cubed minus 2x. So we have a 7th degree polynomial, and that 7th degree polynomial is being raised to the 6th power. So this is an example of function composition again. So the inner function is x to the 7th minus 5x cubed minus 2x, and the outer function is x to the 6th is the function that's sitting there. So there's two ways that we can tackle this. We can do it with and without substitution. If we do it with substitution, we're really thinking of it in terms of this formulation of the general chain rule. So dy dx equals dy du times du dx. And the way that you apply this technique to find the derivative of a function is you let u equal the innermost function, the function that's being input into the other function. So in this case, you would let u equal x to the 7th minus 5x cubed minus 2x. And then the outer function is going to be the function y equals, and I'm replacing this stuff here with u, so it's going to be y equals u to the 6th. So we get y equals u to the 6th power. And then the derivative of it, dy dx, is equal to dy du times du dx. So first you take the derivative here, du dx. So du dx, which is going to equal, now I can just apply the general power rule. This is x to the 7th. So the general power rule says bring the 7 down into the coefficient position and reduce the exponent by 1. Minus, now I have a constant multiple of x cubed. So it's going to be the constant multiple times bring the 3 down into the coefficient position and reduce the exponent by 1. Minus, I have a constant multiple times x, and we know that the derivative of x is just equal to 1. So we get du dx equaling 7x to the 6th minus 15x squared minus 2. And then we need to find dy du. So dy du, the derivative of y with respect to variable u. And that's just going to be the general power rule. Bring the 6 down into the coefficient position on u and reduce the exponent by 1. So we get dy du equals 6u to the 5th. And then I can find the derivative dy dx. Remember, dy dx is just a synonym for f prime of x. So if I'm being asked to find f prime, I'm also being asked to find dy dx. So dy dx by the chain rule is equal to dy du times du dx is equal to, I know what dy du is, it's right here, 6u to the 5th, 6u to the 5th power, times du dx is sitting right here, 7x to the 6th, minus 15x squared minus 2. And then we need to go one more step. We made that substitution. We let u equal the polynomial that was inside of the 6th power function. So we have to substitute back. So it's going to be 6 times u to the 5th power, but u is just equal to x to the 7th minus 5x cubed minus 2x, and then it's times the 7x to the 6th minus 15x squared minus 2. And then I'd leave it like this. It's in a factored form, and factored forms are usually nice forms to have functions in. So you could multiply everything out and then combine like terms, but raising this to the 5th power would be onerously difficult. There's no reason to do it. So just leave it in a factored form. I'd say this is as simplified as we want it. So that's finding the derivative using the chain rule with a u substitution. I can find the derivative without doing a u substitution. And to do it without a u substitution, it's probably more useful to think of it this way. So if I start off with f of g of x, and I'm kind of being a little bit naughty. I'm using f here, and the f here isn't the same as this f, so it's a little bit naughty, but I'm going to be naughty. I'm going to do it anyway. So if we have this guy sitting right here, x to the 7th minus 5x cubed minus 2x to the 6th, this equals, if I want the derivative of that, if I want f prime of that mess, so I want d dx of f of g of x. I want to take the derivative of the composed function. Well, what does the chain rule up here say? It says take the derivative of f, and f has to be the outermost function, which is the 6th power function. Take the derivative of the outer function. So that's going to be by the general power rule, bring the 6 down into the coefficient position and reduce the exponent by 1. So f prime of g of x. So this is the g of x function inside of here. So x to the 7th minus 5x cubed minus 2x. There's the f prime of g of x times multiplied by the derivative of the inside function. So now you have to take that inside function and you multiply by its derivative. So you get your 7x to the 6th, applying the general power rule to x to the 7th gives you 7x to the 6th minus the general power rule. I have a constant multiple of a function to which I'll apply the general power rule. So the 3 is going to come down into the coefficient position and get multiplied by the 5 to give me the 15x squared. And then I have a constant multiple of x, so I'm going to get minus 2 because the derivative of x is 1 and 2 times 1 is just 2. So there is directly taking the derivative, applying this. Now why I said this is naughty is because I'm using f as my function name here. I probably shouldn't use f here. I should probably use, h everywhere I see an f, so that I'm taking h of g of x, right? Function names are arbitrary, so I should be letting f of x equal the composed function h of g of x. And in this case, we want to recognize that the g of x is the x to the 7th minus the 5x cubed minus 2x, and the h of x is going to be the x to the 6th power, the outer function. So usually not good to use the same letter. It kind of mixes things up a little bit.